All right, welcome back. Module 3, Lesson 11. I've got some subscribers now, so woo, need to make some new content. Anyways, today's lesson is how can I subtract fractions making like units numerically? So similar to before, this lesson is getting towards the numbers numerically, but you might still need to use an area model to picture this, so I definitely want to work on that, because if you're ready for numerical, you probably don't need this video very much. All right, so the key thing that I want people to realize is that in these problems, if you're subtracting numbers, for instance, 2 and, let's see, 1/5 minus 1 and 1/7, the key thing I want you to realize is that these two fractions are what I like to call hard because they have different denominators. All right, we have two different denominators, so we want to make sure that we give them the same denominator, and that's what this video is going to be all about. All right, there are two ways we could solve this problem. So the first thing we could do, which I want to start with because I want to work with my develops here, is we can show this by using an area model. Might not be the fastest way, but this is the way I really want to work on in this video. So the first time we need to show thirds. That was messy. Thirds. So to show our thirds, we're going to break this apart. 1/3. Second place over here, we need to show fifths. 1, 2, 3, 4, 5. And we want 1/5. So to do that using the area model, we need to make sure that we put our fifths over here. 2, 3, 4, 5, and we want to put our thirds over here so we can turn these into a common denominator. So here we have 3, 6, 9, 12, 15. And over here we're going to have 15ths also. So how many do we have colored in? 1, 2, 3, 4, 5 15ths. And over here we have 3 15ths. And when we subtract that, 5 15ths minus 3 15ths equals 2 15ths. All right, so this is definitely a skill we worked on earlier in the year, but I want to make sure we're really good at this before we move on to doing this numerically. All right. All right, for this problem, problem number 2, I want to make sure that you get a chance to solve this, so I'm going to get you started, and then you're going to do the rest. So we need 3/5 minus 1/6. So in our model, we need to show 3/5. 1, 2, 3, 4, 5. Oh, that one's much better than earlier. And then we need to show sixths. So I'm going to do the half first. Fix that up. Let's see how good that is. 1, 2, 3, 4, 5, 6. Perfect. All right, so let's show 1/6, and we want to show 3/5. All right, so just like before, we need to split these apart so we have a common denominator. So let's split this into sixths. One, 2, 3, 4, 5, 6. Perfect. Over here we want fifths. 1, 2, 3, 4, 5. Good. Then we just need to write the fractions down the bottom. So over here we have 1, 2, 3, 4, 5, 6 times 3 is going to be 18ths. Whoops, I just did that wrong, didn't I? I mixed up my numerator and denominator. We have 18 on top. And our denominator, if we did 5 times 6, is going to be 30. So over on this other side, which was 1/6, is now 1, 2, 3, 4, 5. 5/30ths. And now that we've done all that, this is very easy to subtract because, of course, they have the same denominator. So 18/30ths minus 5/30ths is going to equal 13/30ths. I accidentally went ahead and solved the whole thing on the last problem. Oh well. So for problem number 3, we now have a mixed number here. All right. So it's going to change it just a little bit. But of course, what I want to make sure you realize is that down below here, these fractions are hard to add because they have different denominators. So it doesn't really matter about the mixed number. We just want to make sure they have the same denominator, and then it'll be much easier to solve. So to start with this one, we want to make sure that we probably start going over to using some sort of numerical way to solve this. You could do it with an area model. You'd have to show 1 whole plus that 3/4, and then you'd have to subtract 3/5. And you could do it that way. I'm not saying you couldn't do it, but I want to get people over to the numerical side. So we're going to start doing this right now. So to do that, we need to find a common denominator. So I'm going to list the multiples of 4, 4, 8, 12, 16, 20, 24, and that goes on forever. Then I'm going to list the multiples of 5, so we can find the least common multiple. 5, 10, 15, 20, 25, and that goes on forever. So when I look, the least common multiple I see is 20. So we're going to rewrite this now. So we're still going to have 1 whole, and now our denominators are going to be 20 minus something that is 20ths. So we're going to figure out what. So to figure that out, we're going to look up here and we're going to see that the one that has 4 as a denominator, we need to do times 1, 2, 3, 4, 5 times 5 times 5. The one that has 5 as the denominator, we're going to do times 1, 2, 3, 4 times 4 times 4. So when we do that, we look back at the beginning and we have 3 times 5 is going to give us 15 20ths. And we look at the second fraction, 3 times 4 equals 12 20ths. So now that these have the same denominator, these are much easier to subtract. So 1 and 15 20ths minus 12 20ths, we're just going to look at the fraction part. 15 20ths minus 12 20ths is going to equal 3 20ths. And of course, we need to bring that whole number over here, so we're going to have 1 and 3 20ths. All right, I want to let you go ahead and solve this one. So I'm going to help you out with a couple tips to get you started. So first of all, you should notice that these are hard to subtract because they have different denominators. So you want to think to yourself, how could you get the same denominator? All right, so as I said, I'm going to get you started. I'm really not going to solve the whole problem this time. So we want to find the least common multiple for 5 and for 2. I don't know why my thing isn't writing. There we go. 5 and for 2. So 5, 10, 15, 20, and so on. And then for 2, you have 2, 4, 6, 8, 10. So you want to try and figure out what is the least common multiple here. And the one that I see that is showing up looks like 10. So you're going to go ahead and use that to turn these two fractions, and I'll help you out a little bit more. Why not? We're going to have 10 as our common denominator. And you're going to go ahead and you're going to figure out what goes up here and here. So that way we can go ahead and subtract these and get one answer. All right, so go ahead, give it a shot. All right, I don't want to help you out this time, so here's the problem. Problem number 5, 5 3/4 minus 3 1/6. So go ahead, try solving this numerically. If you still need to use an area model, that's fine, as long as you get the same answer. That works out great. So you might want to pause this video so you can see it. Click the pause button. Boop.